Thank you everyone for being here. Let's go ahead and dive into these two problems. So these are trig integrals. We have some trig functions, sine, tangent, secant, sine 2x, and we want to integrate them. But the useful tool you'll need to apply for this integral would be some identities. So let me show you how we're going to be doing number one. So I'm going to go ahead and move this out of the way. So for number one, we want to somehow rewrite this piece right here. I see sine 2x, so one useful identity you might want to recall is the double angle. Sine 2x is equal to 2 sine x times cosine x. So that's what I'm going to replace right here, and then try to rewrite. So if I do that, I have the integral of sine squared of x times, now sine 2x I'm replacing with the identity. I'll pull the 2 outside since it's a constant. Then you have sine x times cosine x dx. And now here I'm going to join these two, so that'll be sine to the third power of x. So we have 2 times the integral of sine to the third power of x times cosine of x dx. Now here, you should think of using a u substitution because I see sine and cosine. One of them has power. The one with power, you want to choose that function to be your u. So let's go ahead and select our u to be just sine of x. So then you can raise u to the third power. And the derivative of u respect to x will be cosine of x dx. And that's exactly what we have here. This is our du, and this is our u. We're ready to go in. So our integral now becomes the following: 2 times the integral of u to the third du. Everything nice and smooth. Now use the power rule of integration to integrate this. This would be 2 times the integral of u to the, so you add 1 to the power, 4 over 4, plus c because it's indefinite. And finally, plug in what u is. I'm going to sub this in here, and I'm done with my problem. And then I will simplify 2 over 4. That's 1/2. U is going to be sine. So this is sine to the 4 x plus c. So that is our final answer to this problem. Every time you have even power, you kind of play around with them, even with odd powers. I have done something similar with different powers in a separate video. I'll leave the link in the description box for you to check it out so that way you have more examples done. Here's what I'm going to do. I'm going to rewrite this guy, secant to the 6th x. So we have the integral of tangent to the 4th power of x times, I'm going to rewrite it this way. This is secant to the 4th power of x times secant squared of x dx. Now, the reason I'm doing this because I'm thinking if I pick my u to be secant, then my derivative is right here. So I want to reserve that for the du portion of this problem. So the only thing now we need to do is to modify this piece right here. I want to rewrite that in terms of tangent so that everything can be replaced in terms of tangent, and you reserve secant squared x dx for the derivative of u. So I'm going to rewrite it this way. So we know secant squared of x is equal to tangent square of x plus 1. So that's the identity we're going to apply. So I'm going to rewrite the power 2 this way. So we have the integral. So this is tangent to the 4th of x. Then secant to the 4th, I'll rewrite it this way. Secant square of x, raise that to the 2nd power. So that way you were adding the exponents. This will give you still secant to the 4th. We're just writing it in a fancy way. All right, so now I'm going to replace this identity right in here so that I have everything in terms of tangent. And we're still reserving that one factor of secant for last. So keep rewriting. So you have tangent to the 4th of x. Then here I have tangent square of x plus 1 all over square. And this is secant square of x dx. All right, now we're ready to go with our substitution. So we've been playing around so that way it works. Now you'll see that this works really nicely. So we're going to let u to be our tangent. Let u be equal to tangent of x. then the derivative of u will be secant square of x dx. And this is what we got right here. This is our du, and this is our u, and this is our u. We do the algebraic simplification, and then we're ready to go. So I hope this is making sense. So let's go ahead and proceed. So our integral becomes, in terms of u variable, this is u to the fourth power times u squared plus 1 squared and du. I hope you can see that. Now here we need to do some expansion right here. So if you have u squared plus 1 to the second power, well, that just means they have the same factor twice. So this is u squared plus 1. We're going to distribute. So this would give you, in this way, this is u squared times u squared. So that would be u to the fourth plus u squared times 1, and then u squared times 1. That's 2u squared plus 1 times 1. That will just be 1. So that's what we're going to replace right in here. So we're still simplifying before we proceed to integration. So we have u to the fourth, and the parentheses term I'm replacing it with u to the fourth plus 2u squared plus 1 du. All right, so all of that was on the side. Now we distribute this, and then we're ready to do the fun stuff, integration. So this is the integral of u to the 8th power. You add the exponents since you're distributing, plus 2u to the 6th power plus u to the 4th power. And now we're ready to integrate this respect to u. So the integral of u to the 8th, that will be u to the 9th over 9 plus 2 integral of u to the 6th, that will be u to the 7th over 7 plus integral of u to the 4th, that's u to the 5th over 5th, and of course, plus c. So we're almost done. Now we just need to plug in what is u. Well, we know u is right here. It's tangent of x. That's what I'm going to substitute for u. So our final answer, it's going to be the following. So I can pull out a 1/9. This will be tangent to the 9th of x plus 2 over 7 tangent to the 7th of x plus then tangent to the 5th of x. And I can pull out a 1/5 right here. Plus c. So there you have it. This is our final answer for this example. Alrighty, so I hope this makes sense.